All right, so we're here with our first period, and we're going to start the unit talking about systems of linear equalities, and we're going to talk about how to graph them to solve a system. All right, now, the reason this comes after the unit on linear functions is because a linear system is a system that has two linear functions as a part of it. Okay, so this whole week we'll be talking about linear systems. All right, today is all about graphing, which is why you have a ruler. So let's go ahead and look at this first example. All right, when you look at this first example, what do you notice about both of my functions that are in this system? What do you notice about both functions that are in this system? There's something even more before we even get into like what the Y-intercept is. What do you notice about both of them? We're getting into specifics here. I'm talking about just very generic. What do you notice about each of these equations? Yeah. Yeah, I mean, you're talking about specifically the slope of them. Not point slope form, they're in slope-intercept form. They're both in y equals mx plus b. Plus b. So the first thing, bless America, I swear, I will come through this surface. I will come get you. I swear, I'm gonna just. Why don't you like me? Maybe if I go down here. Okay. First thing you must do is make sure they're in slope-intercept form. So in this first example, they're both in slope-intercept form. So we didn't have to do anything. All right, but you're going to see as you do more problems today that you're going to have to do some work first to get them into slope-intercept form, which we've already practiced in the previous unit. Okay? So let's look at the first one. Y equals x minus 3. What is the y-intercept for this one? It's 0, negative 3, right? Getting that habit again. So let's put a point at 0, negative 3. Okay? What is the slope of this first linear equation? What's the slope? There's nothing in front of the x, so it's 1. And if you want to write 1 over 1, that's fine too. So you're telling yourself to go up 1 and then right 1. Make sure you go to the right because it's a positive slope. So I'm going to go up 1, right 1, and put a bunch of points. No, I'm not. There we go. And then down 1, left 1. Now each of you should have a ruler. So then take out your ruler. But you've got those points. Put that box over there. And make the line. Yours should look perfectly straight because of your ruler. I don't, thank you though. Okay, so any questions so far on how to do the first line? Where did I put the dots? Well, I started at 0, negative 3, because that's the y-intercept. So go on the y-axis to negative 3. And then the slope is 1 over 1. It's a positive. So I went up 1, right 1. All right, and then Lysandra to go the other way, down 1, left 1. Yes, Joseph? I mean, you can. Like, I'm just doing an example here. Right? Since I have a ruler, Josie, like if I'm sitting down, I would go all the way. All right? Any questions about the first line? Now, because it's a system, this is different than what we did last unit. Last unit, you were done. You graphed the line, you're done. Now we have a second line. What is the y-intercept for this line? 0, negative 1. So I'm going to go to 0, negative 1, and plot my y-intercept. Now, what is the slope of this second line? What's the slope of the second line? Negative 1, 1. So now what I do is I write a negative 1 over 1. And you know I always go up. I always go up. And because it's a negative slope, I'm going to go to the left. So up 1, left 1. Now as I'm moving in this direction, what do you notice? I'm getting farther and farther away from the other line. But watch what happens as I go down 1, right 1. You'll notice that these lines are going to intersect. that intersection point is called the solution. Okay? So today, with graphing, you're looking for the intersection point of your two lines. Okay? So let's see. Use a different color here. What is that ordered pair? What is that ordered pair? Very good. ISO 1, comma, negative 2. Well done. Now, this is what I'm going to do that's a little bit more than you need to, but I want to show you something about this solution. All right, so if you want to write this, you can. If you don't have to. You could write it below the slide where you just graphed, or you could not write this. It's up to you. All right? So the first equation was y equals x minus 3. If I plug in 1, negative 2, I'm going to put negative 2 in the y and 1 in the x. And what is 1 minus 3? Negative 2. So this results in a true statement. Okay, let's try the second one. The second one said y equals negative x minus 1. So negative 2 equals the opposite of 1 minus 1. And what is the opposite of 1 minus 1? Also negative 2. So you get a true statement in both. So this solution makes both of these linear equations true statements. This is the only point that will do that. There are other points that you have graphed that will make one or the other, right? All of these points would make the first one true. All of these points would make the second one true. But there's only one point that makes both of the equations true. It makes the whole system true, and that's why this is the solution. Questions? Yes, Jennifer. When we're graphing to solve a system, we're looking for the intersection point, because that's the point that makes both of these equations true. Any questions? Pretty good on the first one. Excellent. Okay, let's go to the second one. Okay, now look at this one. What do you notice when you read this system? They're not in slope-intercept form. So that's that extra step that we have to do first. Okay? So let's look at the first one. It's blue. All right, so when you look at this one, my x is not on the other side. So when I move it over, what does it become? Negative x plus 6. So make sure you see that it was a positive x. When I moved it over, it becomes a negative x. Now, is it there yet? No. What do I have to do to get rid of that 2? Divide. So I'm going to have y equals, now watch this. We already have a negative 1. So when I divide by 2, it's going to be, I think I heard Daniel say it, negative 1/2 x. And then what about this 6 getting divided by 2? Plus 3. Very good. Anybody have any questions about how we got that one in slope-intercept form? So I moved the x over first, right? It was a positive x, now it's a negative x when I move it over. Then I divided everything by 2, so everything got divided by 2. Okay? If you need to show all of the work, you're going to get a chance to practice later. Show all of your work. Okay?
I have a question.
Yeah.
You know how in the first example, graphed the negative 3 on the Y-intercept?
Doesn't matter which one. What do you mean?
Which Y-intercept you choose to graph first?
There's only one. You're talking about which line to graph first? Like, there's only one y-intercept of negative 3. This is the only value on the y-axis that's negative 3. I don't care if you graph the second line first or the first line first.
So like the first one, or no, it has negative 3 or negative 1. Does it matter which one you graph like first?
If you're talking about graphing this entire line first, that's fine. I don't care the order in which you graph the lines, but they are separate lines, so don't start mixing and matching y-intercepts. Okay? Yes, Brianna. First one. This one right here? Because this is the ordered pair where they intersect. That point is on both of the lines. So when I graphed the first one, I had that point. When I grabbed the second one, when I was doing the negative slope, I got that point as well.
The intersecting point is our axis?
Correct. When you're graphing, the intersection point is the only point that makes both equations true. So it's the solution to this system. That's a good question. Okay, awesome. Okay, that was just the first one. Let's do the second one. Do you see how it's a positive x here? So when I move over this positive x, it's going to be negative x. Now be careful. There is a subtraction sign in front of the y. So my y stays negative. Equals negative x plus 3. Now how do I get rid of this negative here in front of the y? Divide everything by negative 1. So everything becomes the opposite, okay? So we have y equals x minus 3. Does everyone see how everything becomes the opposite? Everything became the opposite. Okay? Now let's graph the first one. What's the y-intercept for the first one? This first one. 0, 3. And what is the slope of that first one? Negative 1/2. So I'm going to go to 0, 3. Yeah, I mean, you got to do it all. Oh, you mean like this here? No, I don't need to see that. Right, but if I look at your graphs, Lysandra, and they're not correct, I'm going to ask you to start putting that. Because maybe you're just not writing the correct information first. But yeah, you're asking, do I do this? I do not. I do all of this first. I definitely do all of that, because I need them in slope-intercept form. But this part here is just to show you what I'm using to plot. Good question. All right. Now the slope is negative 1/2. So I'm always going to go up. So I'm going up 1. And because it's a negative, I'm going to the left 2. So up 1, left 2, and I'm putting a point. Okay, so if I'm going up 1, left 2, to go the other way, I'm going down 1 and right 2. That's not right 2. Okay, and then use that ruler. Okay, yes, David. Why did I change? Oh, the second one? Okay, so you see, are you good with me on how I got here? Okay, so to get rid of this negative in front of the y, I have to divide everything by a negative 1. And when you divide stuff by a negative, it's going to become the opposite sign. So everything here becomes the opposite sign. So that becomes positive, that becomes positive. This 3 becomes a negative. Any questions on the first line that I just graphed? No, everybody good? Okay, what is the y-intercept for the second line? The second line. 0, negative 3. You're plotting that. What is the slope of my second line? There's nothing in front of the x, so it's 1 over 1 again, just like we had on the first example. So I'm going up 1. It's a positive slope, so I'm going to the right 1. And you should see we're actually going to get our point going this way. Da-da-da! Got it. That's the sound I make when I get it. Everyone has their unique sound. My teacher used to go, woo, when they would get the point. It's too early for wooing? Okay, stop. I'm sorry. So what is this ordered pair that's the solution for this system? Right, so it's positive 4, positive 1. Now, I'm not going to show you that when you plug it in, you get a true statement, because I showed it in the first one. You don't have to do that. All right, but if you were to plug in 4 and 1 into x and y in both of these, you would get true statements for both. Okay? Yes, Ashley. This one right here, this slope. So do you look in front of x for your slope? If there's nothing in front of x, it's 1. If the slope is 1. I put 1 over 1 to make sure I go up 1 and right 1. This one here, so the slope is -1/2. So when I do a negative slope, I always go up. So you go up your numerator, up 1. Because it's a negative, I'm going to go to the left 2. Okay? Any other questions? No other questions? Okay, so